Right now, we are witnessing an AI revolution. Everywhere you look, AI is making waves, transforming industries, redefining job roles, and reshaping the way we build software. But here's the real question. As a senior architect, a data scientist, or an ML engineer, what does this mean for you? How do you navigate this shift? In this video, I am sharing insights that I have learned from Chapter 1 of Chip Huyen's book, AI Engineering Building Applications with Foundation Models. This is not an exact summary of the book, but rather my own interpretation and learning of key concepts that stood out to me as a solution architect. We all know AI has been around for decades, but something changed recently. The book points to one major catalyst, ChatGPT. Now, whether you love it or hate it, there's no denying that it captured the public's imagination like never before. And that's the key. It wasn't just about the tech, it was about how accessible and tangible AI suddenly became. For the first time, people outside of tech could see and experience AI in action, and that moment set off an unstoppable chain reaction. Massive investments, rapid advancements, and an entirely new category of engineering, AI engineering. The book highlights a striking fact. AI engineering is now the fastest growing field in software development, surpassing even web development tools on GitHub. That's huge. And as architects, we can't ignore it. One of the biggest shifts in AI engineering is moving away from building everything from scratch to adapting pre-trained models. Think about it this way. In traditional software engineering, we don't build databases from scratch. We use PostgreSQL, MySQL, or MongoDB because they are optimized, tested, and scalable. The same thing is happening in AI. We are no longer training models from zero. Instead, we are fine-tuning and integrating foundation models like GPT, BERT, and 𝗫𝗄. For senior architects, this changes the game. It means our focus is less on the deep math behind AI models and more on how to integrate, optimize, and deploy them efficiently. It's about choosing the right model, fine-tuning it for business needs, and ensuring it scales without blowing up compute costs. A major breakthrough that made modern AI possible is self-supervision. Self-supervised learning is a game changer because it allows models to learn from massive datasets without explicit human labeling. Instead of manually tagging every piece of data, AI models learn by predicting missing pieces of information. For example, in mass language models like BERT, words in a sentence are missed, and the model must predict what's missing. This forces the model to understand context, making it incredibly effective for comprehensive-based tasks. On the other hand, autoaggressive language models like GPT-3 are differently. Instead of filling in the blanks, these models predict the next word in a sequence, generating text one token at a time. This is why they are so good at producing fluid human-like text. These two approaches, MLMs for understanding and ARLMs for generation, are fundamental to today's AI applications. For architects, understanding these distinctions is critical because choosing the right model for the right task impacts everything from efficiency to scalability. Now, let's talk about something that's on everyone's mind, the impact of AI on jobs. There's a lot of fear, and for good reason. The book cites research showing that jobs like translators, tax preparers, even writers are at high risk of disruption. But here's the thing, AI isn't just a job killer, it's a force multiplier. It's all about adaptation. The key takeaway, don't compete with AI, work alongside it. The most valuable professionals will be those who know how to harness AI to amplify their expertise. So, as senior architects, we should be asking, how can AI help my team upskill faster? How do I anticipate the skill gaps AI will create and adjust hiring strategies accordingly? What workflows can be augmented, not replaced by AI? AI is a powerful tool, and it's up to us to use it strategically. With all the excitement around AI, it's easy to get caught up in the hype. The book gives a great example, UltraChat, an AI chatbot that took a full year to go from demo to production. Why? Because a flashy demo doesn't equal a production-ready product. And that's where senior architects play a crucial role. We need to be the voice of reason, ensuring that AI solutions are sustainable, scalable, and actually useful. Key lessons here. Understand the limitations of AI models. They are powerful, but not perfect. Set realistic expectations. AI is not magic. It requires planning and iteration. Avoid chasing every new trend. Focus on long-term value, not just hype. So what's the key takeaway from chapter 1? AI isn't just a trend. It's the future of software engineering. AI engineering is different from traditional ML engineering. It's about leveraging pre-trained models, handling open-ended outputs, and focusing on user experience. AI isn't here to replace jobs. It's here to augment them, adapt, or get left behind. AI solutions must be built for production, not just for hype. Understanding the AI stack is essential for architecting scalable, robust, AI-powered applications. This is just the first chapter, but already it's clear AI engineering is redefining the role of software architects. So the question is, how will you prepare? If you found this insightful, stay tuned as we dive deeper into AI engineering. Let's navigate this transformation. Chapter 2 will be covered in the next session, so stay tuned. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share.